All right, I think we're live. We're going to start in
Cool.
a few minutes, in 1 minute or two. So if you're already here, welcome. And yeah, welcome back, Yifan, to YFTT. I think this is your second time hosting, right? Um,
Yeah, a second time. I did one, I think like 2 years ago.
yeah, that was the collocation talk, right?
Right,
Um,
right, right.
so yeah, what were the differences between working on that project versus the one we're going to talk today, auto analyze?
Well, for that one, I think first of all, it's a project involved many teams, and it got involved many features, backup, restore, X cluster, etc., etc. So I have to do many cross team communication.
Got it.
For this one, although I still have some cross team communication, but less than collocation.
Sense. Yeah, I think actually both projects had a lot of interactions with other things here. It's obviously with the cost-based optimizer and analyze sampling and the cache invalidation and so on, things we're going to talk about. But yeah,
Yeah.
if anybody wants to check out the previous talk, that I think episode 58, that's the talk on collocation. But I think we're on 9:30, so we're going to start in a few seconds. So let's just wait 10 more
Cool.
seconds. All right, so let's start. Hi everyone, welcome to I think it's episode 146 of YugabyteDB Friday Tech Talks, talked by engineers for engineers. I'm here with Yifan, software engineer in our language layer team in our kind of like SQL layer. So Yifan, I'll let you introduce the topic for today. Please go ahead.
Yeah, sure. So, hi everyone. I'm Yifan. I'm one software engineer on the YugabyteDB database team. Today, I will talk about the new feature auto analyze in YugabyteDB. So, here's today's agenda. First, I will talk about the basics of an analyze, and I will briefly go over the architecture of YugabyteDB and do a deep dive into the auto-analyze service architecture. Finally, I will do a demo to show how auto-analyze helps query performance. So so what is analyze? Analyze is a SQL command used to collect statistical data about the contents of tables and store the resulting stats in system catalogs such as PG statistic, PG class, etc., but mostly just PG statistic for single column stats. And also up-to-date statistics help cost-based optimizer create optimal execution plans for queries to speed up the query performance. So let's take a look at one concrete example. In this example, we have a distributed table with two tablets, each containing rows. By the way, since YugabyteDB is a distributed SQL, a table is sharded into a smaller unit called tablet for high parallelism. Then we select a random sample of rows from this table. For large tables, YugabyteDB uses efficient block-based sampling to avoid scanning every row. This is available in upcoming YugabyteDB 2025.1 onwards. After selecting a set of sample rows, these rows are fetched. And stats is calculated based on these fetched rows. The stats collected by analyze include a list of number of distinct values, most common values, and the frequencies of these most common values, etc. So let's look at one stats example. On the right, I have a table called orders. It has an order ID as its primary key, integer type customer ID, and the text type column status, and also a timestamp type column called created at. On the left, I have a system view called pgstats. So by the way, pgstats is a system view presenting the underlying statistics in a more human-friendly format, because the stats stored in the catalog, such as PG statistic, are hard to read. It just stores some like very raw data. And let's look at let's take the stats of status columns of table orders as one example. So on the left, we can see, okay, for the status column, it has two most common values, completed and pending, with frequency 0.9215 and 0.07885 respectively. So analyze. So why is analyze important, and why is stats useful? Let's continue using the example table orders. And this time we'll create one actual index on the orders table. Let's imagine we have already inserted some rows into the orders table, and without running analyze, the stats is still. And this time we want to query the orders table for all the orders with pending status. And the query optimizer chooses sequential scan initially. And the total execution time is 109 milliseconds. However, after running analyze, the stats get updated, and the optimizer switch to use index scan, and the execution time drops down to 57 milliseconds, which is a huge improvement. So we know, okay, analyze is important. It helps our optimizer to choose optimum plan. But in the example we just showed, we have to run analyze manually. So can we run it automatically without worrying about running analyze by ourselves all the time? In Postgres, there's a daemon called AutoVacuum. AutoVacuum automates the execution of analyze command for tables that have had a large number of inserted, update, or deleted tuples. By the way, we call this insertion, update, or deletion table mutations. So similarly, YugabyteDB has the auto-analyze service feature, which also automates the execution of analyze commands in a distributed SQL environment for tables that have had a large number of mutations. And the auto-analyze service is based on YugabyteDB stateful service framework. YugabyteDB PG core support is also based on such a stateful service framework. We have a previous YFTT talk on it. If you are interested in it, you should check it out. Also, YugabyteDB auto-analyze service is highly available because it is built on top of RAT.
Yeah, and by the way, the PG Cron talk is episode 120 of YFTT, if you want to check that one out.
Yeah, cool. So yeah, let's before dive into the auto-analyze service, let's have a brief overview of YugabyteDB architecture. So yeah, so on each node we have two layers: the upper layer YSQL query layer and the DocDB storage layer. One application can send requests to any node they want by connecting to the node. And then the query layer just processes the request on local node, and the resulting request gets sent to the local DocDB storage layer on T server. And then local T server just on applies the request and forwards this request to appropriate node if needed to the node having the table data the user request wants. So pretty cool. And regarding auto-analyze service architecture, let's abstract away the query layer and the storage layer. On each T server, we have a counter called the local mutation counter. It collects table mutations of committed transaction started on each T server. And periodically, all these mutation counter send mutations to the central auto-analyze service. And by the way, auto-analyze service resides on one of the T server node. Also, the auto-analyze service has a service table called PG auto-analyze service, auto-analyze table. It has 4 columns: table ID, mutations since last analyzed info, and current analyzed info. After receiving all these mutations from local mutation counter, auto-analyze service aggregates mutations to its service table. And specifically, it aggregates all the mutations to the column mutations since last analyzed. And periodically, auto-analyze makes a decision and runs analyze on tables with enough mutations through the YSQL query layer interface. So you might be wondering, what's the definition of enough mutations? So first of all, auto-analyze runs in a deterministic fashion. It runs analyze when table mutations since last analyzed reaches the analyze threshold of a table. There are 2 flags to control the analyze threshold. First one is YSQL auto-analyze threshold. It is the minimum number of mutations needed to run analyze, and its default value is 50. And the other flag is called YSQL auto-analyze scale factor. It is a fraction that determines when enough mutations have been accumulated to run analyze. The default value is 0.1. And finally, the analyze equation is formulated as YSQL auto-analyze threshold plus YSQL auto-analyze scale factor times number of table rows, where the number of table rows is the number of rows we get from the last analyze. So basically, each time when we run analyze, we can know, okay, how many rows a table have. So to make analyze a little bit more on auto-analyze service, to make auto-analyze service usable in practice, it has like we need to deal with a few problems. First, auto-analyze service has the fault tolerance characteristics. If the node hosting auto-analyze service goes down, a new leader node is automatically elected to ensure the high availability of auto-analyze service. In addition, if an analyze fails during its execution, auto-analyze service will retry the analyze in its following iteration. By the way, the analyze should be triggered. Auto-analyze only retries analyze triggered by itself. It won't retry the user analyze, the user issued analyze statement. Also, since Yugabyte DB is a distributed SQL database, we need to propagate updated table stats to all PG backends on all nodes in order to benefit the cost-based optimizer. and each PG query layer maintains its own catalog cache for performance reason, right? So we want to efficiently update the catalog cache on all the PG backend on each node. And to speed up the such a cache refresh, we implement incremental cache refresh mechanism. We probably will cover it in a future Yugabyte Friday Tech Talk. It is definitely a separate topic. So yeah, and now let's do a demo. Do we have any questions so far?
No, I'll let you know. Let's
okay.
Let's get to the demo. It's exciting to see it working live.
Okay, cool. So I have already created a cluster with auto analyze running in the backend. So first, I will create. So first, yeah, I need to enable our cost-based optimizer. Then I will do the same setup as I showed in my slides. So first, I want to create a orders table. I
think you. Yeah, I think. I think
yeah.
You just copied it twice.
Yeah.
By the way, in case folks are looking at it, so this YB enable CBO is the new GUC to enable the cost-based optimizer. If you're on older version, there is this enable Basecamps cost model flag. So you can find all that in our docs. But this is the latest version from what we built. So this has the new GUC.
Yeah, so yeah, and also we have a cost-based optimizer, Yugabyte Friday talk. If you are interested, you should check it out. So yeah, I run this to command twice. So basically, I just do the same setup. I'll create a table named orders and create one index on the status column of table orders. And then let's check if we have any stats. Select from if we have any stats for the table we just created. Cool. As expected, we don't have any stats since we don't have any data in the table we just created. So let's do a simple explain select star from the orders table. So since there's no stats in the for the table, so the cost-based optimizer just just think, okay, let's assume the table has just like 1,000 rows, and it is a default value used by the optimizer. So yeah, let's do something more interesting. Next, I will insert 10,000 rows into the orders table. All of them has the pending status. This time, let's do a explain select star from the orders table again. Okay, so we know analyze and auto analyze service does its work in the background. The analyze definitely has run because the row estimation now is 10,000 row, which is correct. Then let's look at the stats. Then let's look at the stats. Stats of the orders table again.
Really, one question, maybe before we look at the stats, one question I think probably a lot of our viewers are well familiar, but since you put explain analyze there, do you want to describe the difference between the analyze statement, which we didn't run here, it ran automatically, and the explain analyze, like the analyze option of explain?
Yes. So analyze, if we just run analyze on a table with a table name, then we do the analyze stats calculation on a table. But here, when I do explain analyze and followed by the query, so basically it shows you the query plan, the statement uses, and also actually execute the query. So it can provide you the execution time and memory usage.
Yeah, so I know. Yeah, so this is just a name coincidence. It's yeah. Please go ahead. So here we didn't run analyze; it just run automatically in the background.
Yeah, here all the analyze is just triggered automatically in the background by the auto analyze service. So yeah, let's see some stats on the orders table, and particularly let's look at the stats column. Okay, so previously we don't have any stats at all. Now we have stats for the status column. Its most common value is pending as expected with frequency 100%. Yeah, and the number distinct value is also 1.
Yeah.
Okay, cool. So next I will do something more interesting. So I will insert 90K rows with completed status into the orders table. And then immediately after the insertion, I will do a explain, analyze, select star to query the orders table to retrieve all the rows with a pending status. So that I can make sure, okay, analyze having the wrong, and I can see the query plan before auto analyze kicks in. So let me insert 90K rows with completed status into the orders table, and immediately follow the insertion, I query the pending rows from the orders table. This time, query optimizer chooses a sequential scan on orders table, and it do the storage filtering later on after do the sequential scan. And the total execution time is 93 milliseconds. Since time already passed for a few seconds, let's run this query again. Hopefully, analyze has already finished, and we can see its effect. Okay, so after the stats get updated, auto analyze switched. The query optimizer switched to use index scan on the index on status column instead of the previous sequential scan, and then the execution time drops to 60 milliseconds, which is a big improvement.
Nice. By the way, we have a couple of questions here, so let me. So one quick question from Jim is there a way to tell if the stats were generated by a manual user initialized analyze or by the auto analyze service, by Yugabyte auto analyze service?
Oh, yeah, that's a good question. So as for now, we don't have a way to, we don't have an easy way to tell, okay, analyze is issued by a user or by the service. We have to look at the server log to check if analyze is triggered by our service.
Yeah. Yeah, so I think that's the high-level answers right now. There are internal logs that we can use to find out when each was run. But I think that's one of the future improvements in terms of improving the observability of when the auto-analyze service is run. So that's some of the things that we're going to be working on over the next couple of months in terms of improving this. Another question is auto-analyze service at the universe level. That is, can we change the analyze threshold more granular by database or by table? So I think this refers to the configuration flags.
Yeah, that's also a very good question. So currently, no, we have to, it's a universe configuration, but It's on our roadmap. We are planning to support some smaller granularity to control the analyze threshold for each table.
Yeah, exactly. So if you try it today, these G flags are global. They will apply to all tables and all databases. And hopefully not too far away, you'll be able to set this at the table level and implicitly at the database level as well. Nice, thanks, Yifan. Yeah, so I think, by the way, we have 5 minutes left. So I think we're on time. Yeah.
Okay, cool. So let me continue to do some demo. So let's check the stats again. Country name equals to status. Cool. So yeah, the most common values are updated now. We have two values completed and pending with their respective frequency, and it's relatively accurate. So since we still have some time, I want to do a running example. So I will keep inserting rows into the orders table and 1,000 rows each time. And I want to show you, yeah, and I want to show you how I analyze auto-analyze service runs in the background. So you can see the query insert 1,000 row each time. So let's go to the auto-analyze service table. Okay, this one. So let me select star from the PG auto-analyze service table. Yeah, let's wait a few seconds.
Yeah, so this is the internal table where you actually store the data. Nice.
Yeah, this is our internal service table. I just showed in the slide. It stores the mutation data. So initially, the mutation is 0, and after some time, the mutations accumulated to 5,000. Let's run it again. Okay, then it go back to 0. We know, okay, analyze has been ran by our auto-analyze service. So let's do it several more rounds, 5,000.
So how often does this get updated?
Yeah, so the update frequency we have when it's controlled by a G flag. It has a default value for the demo purpose. For the demonstration purpose, I reduce that frequency to 10 seconds.
Got it. Yeah, so then it adds up because I think you are sleeping 2 seconds between each 1,000 rows. So you're kind of seeing it in increments of 5,000 here because you're updating that number.
Yeah. Cool. Yeah, so it runs again. You can see the mutation difference. And if we go back and stop the run example and check the stats again, yeah, definitely the stats change a little bit.
Yeah.
Okay, cool. So this is all for my demo. Let's go back to my slides. Yes, so yeah, finally, I would like to give a very short summary. Auto-analyze service automates the execution of analysis to update table statistics. You should use auto-analyze with cost-based optimizing enabled to improve the query performance. And you can also adjust the auto-analyze frequency by changing the auto-analyze service flags. So basically just tuning the analyze threshold if needed. And we have these configuration G flags available for you to either enable, disable the auto-analyze service, or tune its behavior. So cool. Yeah, that would be all for my presentation. And thank you. If you like our talk, please start us on GitHub and join us on Slack.
Nice. Yeah, thank you. Thank you, Yifan. Yeah, this is a very exciting feature. I think there was one more comment about currently Analyze is marked as a beta feature. So part of the upcoming work here is we are removing that and finally getting it to a GA state. So if you can go back to the previous state, you can already try this out on earlier version where it's in a preview, kind of beta preview, early access state, and you have the older flags. And on newer and some upcoming stable versions, we are going to turn it to make it GA, and then all these flags and usability will be improved by then. So that's the current status, and yeah, I hope folks can give it a try. And again, just as Yifan mentioned, they definitely try it out with the cost-based optimizer because they're designed to work together. Otherwise, you're not really getting the value of the statistics. And yeah, I think that's any final thoughts? Anything you want to add, Yifan?
Yeah, I would say it's definitely a very, very powerful feature. You should check it out. And with auto analyze service and our cost-based optimizer, YugabyteDB is a really good product. You should definitely try it out.
Great. Yeah, definitely. Yeah. So thank you. Thank you everyone for joining. Thanks, Yifan, again for giving the talk. And yeah, please give it a try. And if you have any questions, you can reach out to us on our public Slack or on GitHub or anywhere else, and we'll be happy to answer. Thank you.
Yeah, thank you.